what I want to reproduce here is a scalene triangle, and scalene just means 3 different lengths. So I'm just going to build a triangle with the polygon tool, and then I'm going to try and reproduce it using the side, side, side congruence and the technique of reproducing sides from our book. So let's just make some triangle and just kind of arbitrarily throw some points down here. And I want to end up with 3 different lengths. All right, those each look like they're different lengths. Now I want to reproduce that. So first step is just picking any side to reproduce on a line. So given this triangle, can I reproduce it with the side lengths? So starting with the line tool, and I don't care if it's the same orientation. Maybe I'm going to reproduce AB over here. So remember, to reproduce segments, all we need to do is get the compass tool. And we use the compass to figure out how long AB is without measuring it with a ruler. And then we just pick a starting point somewhere else. Okay, so this circle has the same radius of AB, so I just need to know what that point is. So hopefully you've done this thing, reproducing segments a couple times now. All right, next thing I need to do is I need to know where this point C is, and it's a certain distance away from A, so I'll need to reproduce that length, and it's a certain distance away from C. This is all like reproducing an angle that we tried earlier. So back to the compass tool. I want to find the length of AC with the compass without using a ruler. And so from D, which is my mapped new point here from A, so D is my new A. C is, right, this circle I just made has the same radius AC, so C is somewhere on that circle here. Now, if I know how far away it is from B also, then I can nail it down where it is over here. So I just repeat the compass tool from B to C, extend that out from F, and so my new point that matches C has got to be where these two meet, right there. All right, so let's see, the intersect tool to find that point there. And then I'm just going to use the polygon tool to trace it out. So I have this new triangle, D, F, G, go back to D to finish it. And this should be congruent to that triangle because I ensured that AB was congruent to DF, AC is congruent to DG, and BC is congruent to FG. And there's a theorem in the book that says if the sides of the triangle are congruent, then the two triangles are congruent. So that means they'll have all the same angles going around. So this should satisfy my congruent triangles using the side, side, side technique. So let's save it since I'm signed in. So this is side, 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 congruent triangle. And so you can either download the file or you can get the shareable link to submit. So that would be the download file there. And give it a better name. Surprised it didn't keep the one I had before. So I could either upload the file I downloaded or I could use this link. You can only get links like this that refer back to something like this if you are signed in with a Geogebra account. So keep that in mind. If you have questions about it, let me know. So I copied it. I could submit it now if I wanted to. So again, 2 options for submitting stuff here. You need to perform at least 2 of these constructions. You pick which 2. And then at this point, I could either upload that file, and I can upload multiple files, but I can't do a file upload and a text entry at the same time. So if I'm going to share that link, I would do a text entry. Paste a link in there, and there's one of them, and I can come back to this later to do another. So let's see, what do we got? We looked at congruent angle. I did a congruent segment earlier, side, side, side. Let's do the side angle side. So we need a triangle with a 30-degree angle in order to reproduce it. So after that, the construction should only use these tools here. So before the construction, it's okay to measure something that you started with, or after, it's okay to measure to see if you actually did it right. But to actually reproduce the object, these right here are like using a compass and a straight edge on a piece of paper. So let's see, side angle side. Let's get a new one. So first I need to construct a 30-degree angle so then I can make a triangle, angle of given size. So we need a couple of points to start with. Let's say those two there. And clockwise, counterclockwise, your call. Let's see, from here, counterclockwise, from B is the center, what's going to happen? Counterclockwise, it should sweep downward, I think. I just need to think about that. Oh, there it is. So it put a new point down here, but it gave me that 30-degree angle. So I'm just going to draw some lines through these. So this is my 30-degree angle over there. And if I connected A and A prime, then what I'd be making is an isosceles triangle, because GeoGebra uses circles to make stuff, kind of like I was using with the construction tools earlier. So I think I'm going to pick a different point to make it a little more interesting. I'm going to add a new point, say down here, and then my triangle is going to be ABC. So make any old triangle, as long as it has a 30-degree angle in there. So this is what I want to reproduce, that triangle right there. ABC, and the 30-degree angle is angle ABC. So all right, so this is a lot like reproducing an angle that we looked at earlier. So this is the side angle side triangle congruence that we're looking at here. That's some text. Know what I'm doing. So we're going to go for a side angle side. Please read the book about this too to get a better understanding of what we're doing here. And we're limiting ourselves to tools to do so. We're not using a protractor, we're not using a ruler, we're just using a straight edge, which is kind of like a ruler, but it's got no units on it. And that's just like the line or the segment tool. And then as far as the compass idea, that's a circle with a center or the actual compass tool down here, but not circle with a given radius, because that's like using a ruler too. So you can't use that one. All right, so to make this work, reproduce a side. So I need to produce, I can do any side I want. I could do AB or I could do CB, but I'm not going to do AC, because notice the order, side, angle, side. And AC is not on one side or the other of the 30-degree angle. And I want to make sure I get that 30-degree angle in there directly. So I think just like before, I'll start with AB, but I could start with CB, doesn't matter. Oh, sure, I'll do CB since you asked. So line, so I'm going to put my line down here, and then I'll reproduce CB down here, starting at point D. So now I need the compass tool to reproduce a length. Oops, I did the wrong thing. Escape if you messed something up. I guess I could have done undo. Let's try that again. Line. Here. Oh, I guess the line was still there. Okay, pay attention, Gary. All right, so my line is still down there. I just used the compass tool incorrectly. Let's try that again. First, I have to say, hey, how long are you according to the compass without using a ruler? And then come down to D and use the compass to measure that out. Intersect to mark that point. So we've done this a bunch of times now. Okay, next thing I need to do is get that 30-degree angle. So I want to reproduce that angle there. So the steps for reproducing the angle are, once we have that starting line there, we want to figure out where this point A is from BC, which will give me that angle right there. So to do that, I just keep working with the compass tool. And I say, all right, find me how far A is away from B. And F is my new B here. So this new point A is somewhere on that circle. And I need the right angle. To get that, I use C to A to make sure I can get to the right spot on this other circle. So again, I still have the compass tool. So I say, all right, C to A, how far are you, compass? Compass says I am that far. So my new point A should be right there. Intersect tool. That should be the point I want. That matches A. Now, sometimes when we make these constructions to note which point maps to which point, we'll rename them. So I'm just going to show you some renaming here, which I haven't done before. So this point D is supposed to be the new version of C. And so let's see, where settings, I can give it a new name. And so usually we do something like C, and then we put a little apostrophe after. So C prime is what that's called. It gets renamed. And then if I click on these other ones, I think it'll give me, yeah, so I can rename G as A. Oh, there already is an A prime. But I think if I rename it A prime, it'll rename this other A prime something else. A double prime or something. Ah, A prime 1. Okay, so A prime versus A, so that's a match. And I guess I'm gonna have to move that to rename F as the new B. So usually the way we rename those, again, is by putting a prime after it. So settings, F is the new B, so that would be B prime. So my belief is that this triangle here is a match of that one where I reproduced that angle. Now notice that was a lot like the side-side-side construction. It was the same thing. But I have a different perspective because I want to be sure I have that 30-degree angle. But it's really the same idea. Polygon. So my new polygon, A prime, B prime, C prime, should have AB should be the same as A prime, B prime. The angle A prime, B prime, C prime ought to be 30 degrees. So let's check that. So technically I'm done with my construction. I just want to double check that I didn't mess anything up. So I'm going to measure angle A, B, C, and Geogebra says, it looks like it says that's 30 degrees. Yay! Looks like I did it. Double check a length to make sure. Like the distance from C to B is about 7.4, and so C prime to B prime ought to be the same thing. And A to B, my original was 5. Probably not exactly 5, but close enough, I guess, GeoGebra. And this one ought to be 5, too. Cool. I did my reproduction. So either download it, give it a good name, like side angle side, congruent triangle, or share it if you're signed in. And here's my link. So I could be done with this assignment because I only need to do 2, but let's go do them all. You pick those 2 to do, and give me your link. Go have a good day, you're done. Otherwise, maybe you thought one of the other constructions was cuter. So let's see. Perpendicular bisector is next. So perpendicular bisector means I have to have something to bisect. So I'm just going to make a segment first. And what I want to do is I want to find the middle of this, and I want a line going through there that's perpendicular. So to do that, we just need a couple circles. So this is actually really easy. We just need the, oh, there we go, the regular circle with center tool. So I just say, hey, give me a circle centered here with AB as the radius, and give me the circle centered at B with AB as the radius. And what's going to happen in that case is I end up with these 2 points up here that all are connected between each other in pairs as radii of the same size circle. So intersect, I get that intersection point there, and this one right here, then AB is the radius of both circles. BC is another radius, so that's going to be the same length as AB, and AC is the same length. So I formed an equilateral triangle. So that'd be another cool thing. I could construct an equilateral triangle pretty easy given any length. So I'm just going to throw that in here for fun. Polygon tool up here. So triangle ABC, go back to where you started to finish the polygon, is equilateral because of the way I constructed it. Let's move this down a little. And so is triangle ABD or ADB, however you want to call it. And oops, go back to where I started to finish it. And so now if I draw the line through CD, that cuts these equilateral triangles in half, which cuts this line in half. And because the lines on each side here are congruent, we end up with these perpendicular angles over here. We can double check that, but we need a point there to check. So I'm technically done with my construction, but I just want to confirm that it's true. I'm not making this up. So to confirm that, a couple things I want to know. Is A to E the same as E to B? Oops. Again, sometimes, now there is a perpendicular bisector quick constructor here, but I want you to do it on your own without using that one right there. So that's why I had to list those legal tools. And then I should find that the distance from E to B is the same. Check it out, same thing. Again, I have to switch to the move tool, otherwise GeoGebra's going to try to measure something. And is this really a right angle there? So I'm going to grab that angle measurer here and say, what is angle BEC? And GeoGebra should report back, says, hey, that's a 90-degree angle. Cool, I did it. So I was given, or I started with this arbitrary segment AB, and then I created this perpendicular bisector just by making 2 congruent circles from A to B, starting and then B to A. So perpendicular bisector. All right, next thing we want to do is what? Angle bisector. Well, that's a cute one.